Students, this is a very typical problem on constraint relationship. Okay, so this is looking very intimidating, but actually the problem is very simple. Okay, sometimes the equations tend to be difficult, but that is not a part of physics. As I said many times, that is a part of mathematics. So in this problem there will be four equations, four unknowns, which is going to be bit tedious to solve, but as a physics part is, as far as physics part is concerned, that is pretty easy. Okay, what we'll do in this problem, that we'll jot down all the tensions. Okay, so first you have to calculate how many threads are there. See, this is a thread, 1 2 3 4, total 4 threads are there. So what we'll do, we'll put the tensions over here. So this is one tension, this is same tension T, okay, just a moment, T, T, so all these tensions are T. So if this is T, this is going to be 2T, isn't it? Because every time you find a pulley like this, if this is T and T, this must be 2T. So that we know, that you should not forget this, right? So this since the tension in this thread is T, so this two thread must be 2T. Fair enough. And again we have, the tension in this two thread will be again as well as 2T, but we'll not bother about that because we are just concerned about the, by the way, this is 10 kg. Okay, so sorry about that, because we don't know this. Okay, now what you have to assign, that first thing is that you have to assign all the tensions. So all the tensions are done, right? All the tensions, these are done. Okay, now second thing is that you can assign any acceleration directions to this particular problem. Mind it that you have to find out the accelerations of the this 5 kg only. So let's assume that this body is going down with acceleration a1, this body is going up in acceleration a2, and this body is going down in the acceleration a3. Now this is just an assumption. I may be right, may not be right. So this you can assume in any directions about the accelerations. But if the acceleration is the opposite direction, you will get a negative answer. Don't bother about that. So I am assuming this, and I am assuming the directions downward to be positive. Okay. So what we'll do, as I said, the tension into accelerations, if you add all the tension into acceleration, that sum must be 0. That is the constraint relationship. Look at this. This is, the tension is T. Okay, so T into A1. I am assuming the downward as positive. So I am taking this as positive. T into A1 minus 2T into A2 plus 2T, because this is 2T. Okay, and this is A3. A3 equal to 0. This is the most important part of the problem. Rest of the things I'm quite sure you know it. Okay, so what we are getting, A1 minus 2A2 plus 2A3 equal to 0. That means what we are getting, A1 equal to 2A2 minus 2A3. This is our equation number 1. Okay, all right. Now the equation 2. Equation 2 is pretty simple. We'll take this this as a, just a moment, we'll take this as a system, right? This system is going downward, so downward force is 100 Newton, 10 kg means 100 Newton minus T equal to 10 A1. So that is our second equation. Okay, all right. Next we'll take this as a system. What we'll get, this body is going upward, so obviously 2T will be more. So 2T minus 50 equal to 5A2. That is our third equation. Now we are heading for the fourth equation, right? Because there are four unknowns. Okay, this body is going downwards. So what we'll get? 100 minus 2t, very basic, right? Equal to 10 a3. This is our fourth equation. All right. Now there are four equations and four unknowns. I am not solving this four equation, four unknowns. If you have any problem, you can come down to me. Okay, I'll solve it. But I know from students get some problems in solving this problem. So please try to solve it. Four equation, four unknowns. If you solve it, what we need A2. You will get A2 is equal to 70 by 13 meter per second square. Okay, I'm leaving this to the students. Please contact me. I'll teach you how to solve four equations with four unknowns, and this is the final answer. That means 8 to 5 kg will go down with 70 by 13 meter per second square. Thank you.